Welcome to the deep dive. Today we're looking at Tuesday, December 15th, 2025. And this was not a quiet day for AI.
Not at all. This was a day of, I'd say, major strategic moves. You had innovation pushing for just radical efficiency on one side.
And on the other, these big top-down battles for control. Control of the hardware, the software, and even the laws that govern it all.
Exactly. For anyone tracking the big picture, December 15th was a real wake-up call. We saw NVIDIA basically tightening its grip on the entire AI stack.
Right. And at the same time, the U.S. government stepped into centralized policy, pretty much explicitly saying they don't want state laws slowing things down.
So we've got the papers, the product announcements, the market data, all from this one day. Our mission, as always, is to pull out what really matters for you, the learner, so you can see where this is all heading.
Okay, let's begin where all intelligence starts, research and innovation. The big theme here seems to be efficiency and, maybe even more importantly, reliability.
Yeah, and the headline that grabbed everyone's attention was NVIDIA's technical disclosure on Nemotron 3 Nano.
This is a really fundamental shift in architecture, isn't it?
It is. So Nemotron 3 Nano is an open model family, and it's built on what they're calling a hybrid architecture. Specifically, it's a mixture of experts and MoE design.
And that's where they mix different specialized models together.
Correct. But what they're mixing is the interesting part. They're interleaving traditional transformer layers with a newer, super fast architecture called Mamba-2 state space models.
Okay, let's just clarify Mamba for a second. That's the one that's really good at high-speed sequential processing, right? Makes it incredibly fast for inference.
Precisely. And that speed is why this matters so much. This hybrid approach, it just fundamentally alters the economics of running AI agents.
Because if you have a bunch of agents talking to each other, they need answers instantly.
Instantly. They need low latency, and Nemotron 3 Nano gets a 4 times higher throughput than the last version. It's all about maximizing tokens per second for these new multi-agent systems.
So if that's efficiency for the, let's say, the cognitive side, what about making AI work in the physical world? That brings us to this paper on something called Anchor Dream.
This is fascinating. You can't train a robot if its training video shows its hand, passing right through a table.
Right, the hallucination problem.
Exactly. So Anchor Dream tackles this by first creating these crude but physics-compliant wireframes. Think of it like a really basic physics skeleton.
And then it uses that skeleton as a guide to generate the high-quality video.
That's it. It conditions the video model on that physical reality first. And the results are, well, they're significant. A 36.4% improvement in policy success in simulation.
But the real number is the real one transfer.
Right. And they saw a 2x improvement there.
Yeah.
This is how generative AI stops being just an artistic tool and becomes core infrastructure for robotics.
Okay, so we're making AI more efficient and more grounded in reality. The next piece of the puzzle is making it more reliable when dealing with humans.
And that's where SpeakRL comes in. It's a new reinforcement learning technique.
And the idea here is pretty simple, right? It's basically teaching LLMs to just ask for help.
To ask clarifying questions, yeah. It explicitly rewards the model for saying, hey, I'm not sure what you mean, before it tries to do a complex or ambiguous task.
It sounds so obvious, but it's a huge step.
It is, because it mirrors how human teams work. You train the AI to manage its own uncertainty. It becomes a collaborator, not just a confident guesser.
Yeah.
And this led to a 20.14 percentage point increase in task completion rates. It's all about building trust.
Now, for something that affects pretty much everyone in the knowledge economy, a global white paper from Frontiers on AI adoption in academic publishing.
This really changes how science itself is validated. The headline finding is that 53% of peer reviewers are now using AI tools in their review process.
53%, that's a majority.
It is. So the process of science is being augmented very, very quickly. It's a huge shift.
And speaking of global shifts, rounding out research, there's a new analysis looking at India.
Yes, looking at papers in the Nature journal family. And it ranks India as a leading source of machine learning augmented scientific contributions.
So this isn't just theory, it's application.
It's all application. India is now the third largest source of these contributions globally, just behind China and the US. They're really focusing applied AI on national priorities like medicine and agriculture.
Okay, let's move from the lab into the real world. Segment B, product launches. And it looks like open models are still driving a ton of competition.
They are, and Mistral is still at the front of that pack. They launched their new Mistral 3 family.
What's new here?
The big one is Mistral Large 3. It's got open source multimodal capabilities, so vision and text, and much stronger multilingual performance. It's running on 41 billion active parameters, so they're still laser-focused on that performance-to-cost ratio for developers.
So Mistral is going for global capability, but Abu Dhabi-based G42 seems to be going in a different direction with its upgrade to the Nanda model.
This is a really strategic play. They're asserting what you might call linguistic sovereignty. They have built an open-source Hindi-English model.
And not just fine-tuning.
No, this is ground up. Nanda 87B was trained on over 65 billion Hindi tokens. That means it captures cultural nuance, fluent Hindi, English, things the big generalist models just miss.
Yeah.
That's a massive advantage in a huge market.
Okay, next up, a very different kind of capability. Formal verification. Google Research published results from a pilot using Gemini.
Yeah, this is moving LLMs from just writing essays to doing rigorous formal work. They use Gemini to give automated feedback to authors submitting to the SDOC Computer Science Conference.
So what? It was checking their math?
Essentially, yes.
Yeah.
Verifying mathematical proofs, spotting logical errors in their papers before they even submitted. And the authors loved it. 97% said the feedback improved their paper quality.
Wow. Okay, and finally, a big signal from a creative giant. Adobe announced it's integrating third-party AI models into Photoshop 2026.
This is a huge pivot. They're going beyond their own in-house Firefly model and bringing in best-of-breed models from Flux, Google, and Topaz.
For a company like Adobe that's famous for its walled garden, that's a massive change.
It is. They're basically admitting that the AI landscape is too fragmented for one company to do everything best. They're shifting to an interoperability model.
I have to push back on that a bit. Does this mean their internal Firefly strategy failed? Or is this a pivot to where their real value is the canvas, the user interface, not the engine underneath?
I think it's probably a very pragmatic combination of both. They looked at the market and realized that trying to compete with dozens of specialized venture-backed model labs it's a financial black hole.
So instead of building everything, they become the marketplace.
Exactly. They become the central hub. They keep the user, they control the workflow, and they get to offload all of that incredibly expensive R&D. It's a really smart defensive pivot.
That makes a lot of sense. Okay, let's switch gears to the physical layer, the chips and infrastructure. And on December 15th, NVIDIA made a massive move.
Huge. If Nemotron was about software architecture, this move acquiring SchedMD is all about infrastructure control.
And SchedMD is the company behind Slurm, right? The workload manager.
Yes, the open source workload management system. It's absolutely critical for high-performance computing, for all the large-scale AI training clusters.
Hang on, if Slurm is open source, why does buying the company matter so much? The code's available to everyone.
But this is about platform lock-in through optimization, not code restriction.
Right.
Slurm is the brain. It's the software that decides which job gets which GPU and when.
Okay.
So since Slurm is used by almost every major AI research organization on the planet, NVIDIA can now tune the scheduler to work perfectly with NVIDIA chips.
Yeah.
It gives them this quiet but decisive competitive advantage over any other hardware.
While that's happening, China is pushing forward with its National Integrated Computing Power Network. This sounds like more than just building data centers.
It is. It's a unified, nationally coordinated push. They're trying to meet this insane domestic demand. They're projecting 43% growth in 2025.
And they're also focused on efficiency. I see a metric here, PUE.
Right. Power usage effectiveness. It's basically a ratio of how much power goes to the computers versus how much is wasted on cooling and lights. Their target of below 1.25 is very aggressive. It shows how seriously they're taking national scale efficiency.
Back in the enterprise cloud, Snowflake is adding more AI tools directly into the warehouse. Vector aggregate functions.
This is really critical infrastructure for anyone building RAG pipelines. That's retrieval augmented generation. In simple terms, these new functions let you do complex math on your vectors inside the database.
So you can find clusters of similar things more efficiently.
Exactly. It optimizes your similarity search and makes your RAG results much more relevant without having to move the data around.
But with all this building, it looks like the money is getting a little nervous. We saw continued stock sell-offs for AI infrastructure companies like Oracle and CoreWeave.
There's some real investor skepticism setting in. The big question is whether the revenue that's going to be generated by all this AI will ever justify the massive, massive capital spending.
And some of this is being funded by debt, right?
A lot of it.
Yeah.
When you see a company like Oracle with the debt-to-equity ratio hitting 500%, that means this whole AI build-out is a highly leveraged, financially risky bet.
That financial risk brings us very neatly to policy and governance. And the biggest story of the day was the U.S. moving towards centralization.
Definitely. President Trump issued an executive order to create a national AI policy framework, and its goal is explicit: national velocity.
And by that they mean getting rid of obstacles.
Getting rid of obstacles. The order is designed to preempt and challenge state-level AI regulations, like the one in Colorado, that the administration sees as burdensome. The federal government is asserting its authority to create one set of rules.
So they're prioritizing national speed, but that could mean sacrificing some of those local guardrails. What's the mechanism they're using to enforce this?
They're backing it up with legal force. The EO mandates the creation of a Department of Justice AI litigation task force by January 10th, 2026.
So legal challenges are coming.
That's the signal, yes. Imminent legal action against what they see as restrictive state laws.
And to complement that, there's the launch of the U.S. Tech Force.
This is a really ambitious plan to fix the government's tech talent gap. It's a 2-year tour of service program. They want to bring an initial cohort of 1,000 elite technologists from the private sector into federal agencies.
And it has backing from the big players.
Microsoft, NVIDIA, they're all on board. It's about modernizing government AI infrastructure to keep up with international competition.
Speaking of which, an analysis came out framing China's view of the AI race.
And the framing is really important. It argues that China sees this not as a commercial competition like the U.S. does, but as a matter of national survival and technological sovereignty.
So the motivation is fundamentally different.
Completely. It explains why they're mobilizing the entire state to achieve autonomy.
Yeah.
For you, the listener, it just means you should expect continued friction on standards and supply chains because the goals are just not aligned.
And finally, over in Europe, the EU AI Pact just marked its 1-year anniversary.
This is the maturation of their process. The pact is a voluntary preparatory step for the big EU AI Act. It's now reached over 3,200 participating organizations. It's a very structured, compliance-first approach. Cautious.
Okay, our final segment, funding and adoption. And we start with a huge vote of confidence for AI in biotech. Chai Discovery raised a major round.
A very major round. A $130 million Series B, which values them as a unicorn. This is a huge validation for the whole therapeutic AI agent idea. They claim their models are getting a 100-fold improvement over old computational methods for things like antibody design.
So real results in a very hard scientific field.
Exactly. This is AI delivering tangible value.
Meanwhile, in China, official reports say their core AI industry is shifting from R&D to massive commercial deployment.
Yeah, especially in embodied intelligence, so robotics. The core industry revenue is projected to hit about $170 billion in 2025. It just shows the scale of their industrial AI push.
And we saw a concrete example of that at the University of Science and Technology of China.
We did. They announced the deployment of 110 AI robots running 247 in their labs, doing autonomous experiment design and material synthesis on a platform called ACAM. That's a fully autonomous research. A massive leap in productivity.
But the overall mood in the market isn't quite so euphoric. MIT Technology Review published a piece on what they're calling the Great AI Hype Correction of 2025.
And it's a really sharp analysis. It argues that 2025 was the year of the reckoning. The boundless hype is giving way to more measured, realistic expectations.
Why?
Well, because enterprise adoption has been slower than promised, and the big model updates become more incremental, not revolutionary. It suggests we're moving into a phase of slow, rigorous integration.
And that phase requires reliability, which is a good transition to the news that Microsoft's Copilot had a global outage.
A small but important reality check. It affected hundreds of users, but it highlights that even these mature enterprise systems are still fragile. Downtime is becoming a real financial and operational risk as more companies depend on these tools.
So wrapping up, what does this all mean for you? It seems like December 15th really showed two competing forces. First, this relentless push for efficiency. You see it in Nemotron's hybrid architecture, in G42's specialized Nano model.
And then second, you see the final consolidation of power.
Right.
NVIDIA locking down the stack with the SchedMD acquisition and the U.S. federal government centralizing policy to move faster.
If you're looking for tools you can use today, we have a couple of picks. First, the Snowflake AI Toolkit.
This is an open-source playground built on Streamlit. It lets you build and test our RAG and agent workflows right inside your Snowflake data environment. It's a great way to quickly prove out ideas.
And second, for a different audience, the OpenAI Academy K-12 webinars.
Yeah, this reflects that mainstream adoption wave.
Hmm.
It gives educators real, concrete examples and safety advice for using ChatGPT in the classroom. It's about moving beyond just basic experimentation.
Okay, let's finish with our numbers of the day. They really tell the story of the scale and the central challenge here.
First number, $202.3 billion. That's the total amount invested in the AI sector in 2025. It confirms that AI captured roughly half of all global venture capital this year.
Half of all VC. And the second number, the 90% threshold.
This is the number analysts are pointing to. It's the factual accuracy level they say models have to hit before you'll see widespread enterprise adoption in high-stakes fields like finance or medicine.
So if you connect that huge investment number to the hype correction and that 90% threshold, it paints a very clear picture.
It does. The next big fight isn't about model size or speed. It's going to be about trust. If your most advanced models can only get, say, 2 out of 3 facts right, how can you ever justify that massive debt-fueled infrastructure build-out we talked about? The entire revolution depends on a really boring metric. Absolute verifiable reliability. That's the only thing that's going to matter.